What do you get when you cross the newest iPhone 12, international hackers, and TikTok? You get the field of computer science. In this lesson about careers in STEM, we will focus on the rapidly changing, exciting field of computer science, focusing on different career options in computer science, influential scientists who's changed the field, and what you have to do right now to set yourself for a career in computer science. So what is computer science? Career Girl states that creating and improving software involves working with algorithms, which are sets of instructions that tell a computer what to do. So to summarize, computer scientists write instructions, which is called a code, into computers to generate programs and products that we benefit from, such as TikTok, the various Apple products, and also national security programs. Now let's talk through one specific way computer science affects us regularly. Ever wonder who you can blame for these annoying notifications that are asking you to constantly update your phone or computer? Well, you can blame computer scientists for this. So what computer scientists do is that they identify a problem. In this case, it might be because your computer might be freezing too often. They might want to increase the security by adding another security measure such as Touch ID, or they might be wanting to add a completely new feature such as the newest filter on Instagram. So once they identify this problem, computer scientists will work in teams to again find a solution by writing codes. Once they find the correct code that solves the problem, they will send it out to your individual computers and phones for everyone to enjoy. Now I'll be going over the brief history of computer science and the various inventions that led to the modern computer. Thousands of years ago, the Sumerian abacus was used from 2700 BC to 2300 BC. The abacus was a calculating tool that was in use in the ancient Near East, which is also known as the Middle East now, also in Europe, China, and Russia, centuries before the adoption of the written Arabic numeral system. It was a calculating tool that used beads and other small objects that consisted of rows, which represented the various digits. A few thousand years later, the first computer algorithm was created by Ada Lovelace. Ada Lovelace was an English woman who is credited as a pioneer of computer programming and is regarded as a mathematical genius who worked closely with Charles Babbage. Ada Lovelace became the designer of the first computer algorithm, which had the ability to compute Bernoulli's numbers, which is shown below. Moreover, Lovelace's work with Babbage resulted in her prediction of future computers to not only perform mathematical calculations, but also manipulate symbols, mathematical or not. About 100 years later, Alan Turing invented a universal machine known as the Turing machine. This actually wasn't a physical machine, but instead, it was a system of rules used to decide formal languages and solve mathematical functions. The central concept of the modern computer was based on his ideas. Later in the century, Konrad Zeus developed the first modern programmable computer called the Z3. Zeus was a German civil engineer, inventor, and computer pioneer. His greatest achievement was the world's first programmable computer. The functional program-controlled Turing-complete Z3 became operational in May 1941. Thanks to this machine and its predecessors, Zeus has often been regarded as the inventor of the modern computer. Later in that decade, William Shockley, John Bardeen, and Walter Breitan of Bell Laboratories invented the transistor. They discovered how to make an electric switch with solid materials and no need for vacuum. A few decades later, the Kembac was developed. The Kembac 1 was the first commercially sold computer. The distribution of computers, such as the Kembac, led to the development of various processing programs, such as Macintosh and Microsoft, that were invented later in the 70s. A few decades later, in the 1990s, Tim Berners-Lee, a researcher at CERN, the High Energy Physics Laboratory in Geneva, developed the Hypertext Markup Language, also known as HTML, giving rise to the World Wide Web, also known as the Internet. This invention led to the development of many of the programs that we still see today, such as Google by Sergey Brin and Larry Page later in the 90s. All of these inventions have now led to what we know as the modern internet. Before, computers had to be connected via wires to access the internet, but now Wi-Fi is the norm. Wi-Fi has enabled us to access the internet and various computer programs for mobile devices such as cell phones and iPads all around the world. Now we'll be going over several influential computer scientists in our history. The first is Katherine Johnson, a NASA scientist and mathematician. In the 1960s, President Kennedy announced that he would send the first man to the moon. Getting to and from the moon would be a daunting task, so NASA recruited brilliant minds like Ms. Johnson to make this goal a reality. Ms. Johnson was called the human computer because of her ability to accurately make calculations in her head. She would determine the paths for the spacecraft to orbit Earth and to land on the moon. We'll now watch a news clip about her great contributions.
Katherine Johnson was from West Virginia. She was a mathematician, a pioneer, part of a small group of African-American women hired as mathematicians at NASA. Breaking gender barriers, racial barriers in the 50s and 60s, she worked on the first U.S. manned space flights.
We have a liftoff.
Calculating the precise trajectories that would allow Apollo 11 to land on the moon.
It's one small step for man, one giant leap for mankind.
Her role was long overlooked. Katherine on the far right, her daughter, would hear the stories.
Mama got there at 53. The engineers came and asked for some specific skills. The supervisor said, "Oh, well, that's Katherine."
And what was her role?
The work was to take a Monroe or a Frieden calculator and do the big equations, which could be a page long.
Math is always dependable.
Johnson's role portrayed in the film Hidden Figures.
You have someone?
Oh, yes, ma'am. Catherine's the gal for that. She can handle any numbers you put in front of her.
She would own her role.
We can calculate launch and landing, but without this conversion, the capsule stays in orbit. We can't bring it back home.
You'll remember the movie was nominated for Best Picture.
A true NASA and American hero, Katherine Johnson.
She was also awarded the Presidential Medal of Freedom, the nation's highest civilian honor. And when her daughter asked all those years later, what if someone questioned you?
What happened if somebody questioned your work?
Tough. And so was she, a true American pioneer.
To learn more about Katherine Johnson's incredible contributions to our space program, check out this 2016 film, Hidden Figures, starring Taraji P. Henson as Katherine Johnson. The second scientist we'll be talking about is Bill Gates, the co-founder and CEO of Microsoft.
Bill Gates, co-founder of Microsoft and philanthropist. William Bill Henry Gates was born on October 28, 1955, in an upper-middle-class family in Seattle, Washington. An avid reader, Gates excelled at Lakeside School and did very well in many subjects. In the 8th grade, the Mothers Club at the school purchased a teletype terminal and a block of time on the school's computer. Gates would spend as much time as he could on the computer and wrote his first program at the age of 13, a tic-tac-toe program in basic computer language that allowed users to play against the computer. In 1973, he graduated from school with a score of 1,590 out of 1,600 on his SAT tests. During his time at school, Gates had befriended Paul Allen over their love of computers. They had built a computer program based on the Intel 8008 chip called TrafoData that monitored traffic patterns in Seattle. Although Gates had acquired a place at Harvard University to study law, he would eventually drop out in 1975 to pursue a business with Allen. Gates and Allen were inspired by an article in Popular Electronics magazine on the Altair 8800, a build-it-yourself kit microcomputer. They contacted the company who made the Altair, called Micro Instrumentation and Telemetry Systems, or MITS, who were located in Albuquerque, New Mexico, saying that they were developing a basic software program that would run the Altair computer. In reality, they didn't have an Altair to work with. The company agreed to a demonstration, so the pair worked hard on writing the program. The program worked, and Allen was hired by the company, and Gates would soon leave Harvard to join him. Gates and Allen then established Microsoft on April 4, 1975, with Gates as the CEO. The name was a blend of microcomputer and software. While Gates oversaw the business, he would also continue to write code himself and review it before it shipped. IBM approached Microsoft in July 1980 as they wanted an operating system for its upcoming personal computer. Gates said it could be done, although Microsoft didn't actually have such an operating system for IBM's new PCs. Gates approached a small software company and made an offer of $50,000 for an already made system called 86-DOS, while keeping it confidential who it was for. He adapted it for the PC and delivered it to IBM as PC-DOS for the same price of $50,000. Keeping the source code, Gates required that manufacturers, including IBM, pay a licensing fee. Microsoft licensed the software to PC manufacturers as MS-DOS, making the company a major player in the industry, with sales going from $7 million in 1980 to $16 million in 1981. At the same time, Apple, led by Steve Jobs, invited Microsoft to write software for their computers. Through these collaborations, Gates identified that Macintosh's work-in-progress graphical user interface was much more user-friendly than the text and keyboard-driven MS-DOS system Microsoft currently had. Gates would then soon announce his own graphical user interface, called Windows for all PCs with MS-DOS. In 1984, Apple launched the Macintosh, and a year later, Gates and Microsoft launched Windows. In 1987, Bill Gates, at age 31, had become the world's youngest billionaire. Gates continued to improve Windows and persuaded computer manufacturers to preload it on every computer it sold, and by 1993, Windows was running on almost 85% of the world's computers. This would also cause investigations into Microsoft for unfair marketing practices as a monopoly. In 1995, Gates launched the revolutionary Windows 95 and expanded into the World Wide Web after his Internet Tidal Wave memo. By 1998, Microsoft was the world's biggest company. Gates stepped down as CEO in 2000 to Steve Ballmer. Since then, Bill Gates has dedicated his life to philanthropy, funding disease prevention, combating poverty, and improving education around the world.
To learn more about Bill Gates and his work, check out the Netflix series Inside Bill's Brain: Decoding Bill Gates, where Bill and his team works to find solutions to some of the world's most pressing issues, such as access to clean water and vaccinations. Now, the question I'm sure people are wondering is, how much do computer scientists actually make? It turns out that computer scientists, on average, are very well paid. According to the 2018 U.S. Bureau of Labor Statistics survey, the average salary for computer scientists was $86,320, which was almost $40,000 greater than all other jobs. The salary is also highly dependent on the specific field of computer science you pursue, with software engineers and application developers making on average $100,000 or above. Finally, the future continues to look bright for computer science. The 10-year projected growth in jobs is faster than the national average, with the job market for application developers, the people who make apps like TikTok and Facebook, looking the most promising. So now that you're interested in a career in computer science, what do you have to start doing now to become one? We'll be going over key actions you can start taking this year to begin your journey to be the next Katherine Johnson or Bill Gates. In high school, it'll be really important to excel in core classes such as math, specifically calculus, statistics, and English. Foreign languages are also extremely helpful since coding requires learning a new type of language. If available, courses such as AP Computer Science and Engineering can also be really great experiences to learn more about the field. In terms of extracurricular opportunities, there are many summer camps available for students at all levels and ages. Many universities, such as UT Dallas, have summer camps to expose people to computer science. Additionally, there are many organizations such as Code Ninjas and Code with Classy that offer summer camps for coding to students all over the country. And finally, there are many websites that can help you learn computer science all by yourself. Now we'll be watching a short film about Code with Classy, a summer camp that is free for girls interested in computer science.
I've always been really interested in STEM, and I was looking for summer programs for girls where I could expand upon my knowledge.
You learn a lot, not only about coding, but about other places and about other girls. In the schools that I went to, I didn't have the option to take any form of computer science or coding classes.
I was just ready to learn.
Being in the Code with Classy environment is amazing
because we all have that mentality of like girl power, we can do this.
Trying to help each other, we're all trying to reach the same goal.
Once you just start to get the basics, seriously, you have the whole world at your fingertips.
Seeing Sophia in level 2 is so cool. They're coding VR and drones.
The best experience I've had at Code with Classy is designing this web app.
I mean, when I heard the first time that we were going to learn in VR, my mind was blown.
Young women should get involved with coding because coding is literally something that can be for everyone. It can be for the artistic person, it can be for the mathematical person, the logistics person.
All I can say is just go for it, don't let it intimidate you. Take that risk, like you have nothing to lose and everything to gain from here.
Women are underrepresented in STEM fields,
but I
am changing that.
So in college, you'll want to get a bachelor's degree in a computer-related field, such as computer science or computer engineering. Many colleges will also offer sub-concentrations in specific fields, such as computer systems, cybersecurity, game development, and artificial intelligence. The goal of college is to learn different coding languages, such as Java, Python, and C++, so that you're gaining as much experience to find a job after graduating. Additionally, there are many extracurricular opportunities for computer science majors. Many schools host hackathons, which are all-night events where groups of students will work together to produce a new application or to solve a new problem. Many students can also find work with a local business, which are always looking for new computer scientists. And finally, some students even start their own businesses through projects that came up from one of their classes. Some schools in Texas that are especially known for the computer science programs include Rice University, UT Austin, Texas A&M, Southern Methodist University, and UT Dallas. Computer scientists will often also pursue internships and graduate schools to further their education and experiences. The goal of summer internships is to gain real-world experience working for a company. Many computer science summer internships will be paid, although some may be unpaid. And then if you excel during the summer internship, many students will leave with a job offer for after they graduate. Many positions within the computer science field will also highly prefer or require a graduate degree in computer science. These degrees usually entail 2 to 3 years of study after earning a bachelor's degree, where students will further specialize in a field of computer science. Now that we're done with this lecture portion of this lesson, why should you consider a career in computer science? What skills are needed for computer science? Analytical skills are extremely important. Computer and information research scientists must be organized in their thinking and analyze the results of their research to formulate conclusions. Communication is also integral. Computer and information research scientists must communicate well with programmers and managers and be able to clearly explain their conclusions to people with no technical background. They often present their research at conferences. Computer scientists must also be critical thinkers because they work on many complex problems that are futuristic at times. Computer scientists must be detail-oriented. They must pay close attention to their work because a small programming error, even just one single letter or number in a code, can cause an entire program to fail. Computer scientists must be forward-thinking and creative. Computer scientists must continually come up with innovative ways to solve problems, particularly when their ideas do not initially work as intended. If these skills are skills that you are committed to further developing, then definitely consider a career in computer science. Now we'll be doing an online activity to learn more about what computer science is like. Type in this website into your browser, studio.code.org/s/express-2020. Code.org is a website that has various different programs that go through the different skills that computer scientists often use when developing their programs. Although many of these programs are meant for children, the fundamental skills mimic what actual computer scientists, especially those developing applications and games, will also use. We'll be going over this program called Programming with Angry Birds. The first page of each program will be a video that explains what the goal of the program is. If you would like more information and details on how to complete this task, I would encourage you to watch it in its entirety. Now we're on to the actual activity. The instructions state, for this puzzle, drag all of the blocks together and click Run to watch it go. So our puzzle is shown on the left side. You are the bird, and your goal is to catch whatever critter that you want to catch. I will notice that I need to go forward 2 spaces in order to get to this critter. Therefore, in my workspace, I'm going to have to write a code, which again is a set of instructions that tells the computer program to do what I want it to do. Since I need to go forward 2 spaces, I'll drag the move forward button once and twice, and then I'll press Run to see if I have it correct. The tasks will eventually get more complex, so let's just do one more together. For this next puzzle, I have to move the bird 1, 2, 3 spaces. Again in my workspace, once I click Run, I have to tell the computer what to do. So I want to move it forward once and twice. Let's say that I think that I only have to move forward twice. Let's see what will happen. We didn't quite make it, so we'll reset, move forward one more, and then see if this is the correct code. So now that we have the correct code, I'll give you guys time to go through this entire activity by yourself. Your goal is to pick any of the activities on the previous page and go through all of the different stages and hopefully finish the most difficult stage at the end. I hope you had a good time learning about careers in computer science, and have a good day.